Yo, what's up, people? Yeah, that was cringe, but yeah, we'll discuss today's lead code problem today, which is 2054, two best non-overlapping events. So in this question, you're given events. Events are of the form start time, end time, and value, right? So each event, let's say this event will have a start time, it will have an end time, and it will have a value assigned to it. And you have to pick at most two non-overlapping events. It's non-overlapping like this event and this event. They do not overlap. There is no like time in which both of them are common, and we want to maximize our value. So like in this test case, we can see we can go to the event 0 and we can go to event 1. We'll get a value of 2 plus 2, 4, and this is the maximum value, because if we only go to event 2, then we'll only get a value of 3. So how do we solve this? Let's say, and let's also look at the constraints. So the constraints are that the number of events are 10 to the power 5. Each event is of size 3, which makes sense because it's start time, end time, and the value assigned to it. And start time and end time are 10 to the power 9. Because it's 10 to the power 9, we cannot create a number line or a timeline and then assign to it. So that this we cannot use basically in our solution. And value is also is 10 to the power 6. Okay, and that's fine. But how do we solve this thing? So there could be two cases. One case is that we only go to one event, which is because we can go to at most two events. So one case is that we only go to one event. Another case is we go to two events, right? Now, if we go to two events, let's say this is the first event that we go to. Let's say this is event 1, and let's say this is or let's say EI and EJ, right? So EI would be of form start I. Let's say this is end I. So this would actually like not make sense. Let's actually write this as event I and event j, right? So start I, end I, and value I, and this is start j, end j, and value j. Okay, that makes sense. But what is the relation between these values and these values? Because we want that these two events should not overlap. In that case only we can attend both of them. So can I say that start j has to be greater than equals to end I? Does this make sense? This makes sense, right? Because if this event was like from 5 to time 10, this we can attend if and only the start time of this was greater than 11. It could be 11, it could be 12, but then only we can attend this. Okay, this makes sense. Oh, sorry, greater than 11. Okay, so this condition we know that for the two events has to be true. How do we use this condition? See, if I make a choice on the current event that I'm on, that is event I, what is the next event I can pick? So if I'm picking event I, then the next event I can pick has to have this condition: start j has to be greater than ei. If I know that this condition has to be satisfied, can I binary search on this? I can binary search on this. Basically, I will sort my events, because in any case that we are dealing with events or like L raised to the power L2R, these kinds of things, we have to sort it, because then only we can use some interesting results on it. So sort the events basically means that, let's say if we had some event 0 to 2, 3, let's say this is 1, or let's say this is 1 to 2, this is 0 to 3, 5, and this is 2 to 4, 6. So we'll sort it. Sorting it basically will sort on the first thing, because this is vector sorting is done in lexicographical order. So it will give me 0, 3, 5. It will give me 1, 2, 3, and it will give me 2, 4, 6. So now if I'm making a choice on this event 0, 3, then the next event I can go has to have the starting time greater than this end time. So there is no event on this. So we'll basically binary search on this array, and then we'll find the first index that actually has an index greater to it. Okay, that is fine. So we know that, but here there is no thing. So this will actually not result to anything. Basically, we can, if we pick this event, we cannot pick another event. That is what I mean here. But let's say if we pick on this event, so 1, 2, let's make this 1, 1. So if it is 1, 1, then if we pick this, we can actually pick this event also. So this is a better answer, because we'll get 3 plus 6, 9. If there was many events in between this, right? If there were many events in between this, let's say there was uh, another one event, uh, event, we do not actually need to go and check on this event, because this event we cannot book because of the choices we made earlier. Okay, so can I say that the choice I made at I, the choice I make at I will actually give me my J, my next index that I can pick. So there are two choices I can make at I, right? One choice I can do is that I can pick this event. So that would give me a maximum of, oh sorry, that would, yeah, a maximum of, if I pick this event, that is, then I will get the value of I, that is vi dpj vi, sorry, dpj plus vi. And the other case that I can do is I can not pick this value, then we'll just go to next event and get dpi plus 1, right? Okay, so this is a dp relation. If we were able to pick any amount of, or we can pick any number of events, this would be a dp relation, right? So I pick this event, and I get this vi value, then I go to the next event and I again do my dp calculation for it, and the maximum of that value will use here, and or I do not pick this element, that is fine. But the question is slightly changed here, that we can only pick at most two events. So if we were able to only pick two events, how will a dp relation change, or a recurrence relation? If you are not able to understand dp, let's write it as a recur function, right? So how would it change? So let's say we have a recur function with again making a choice on I, and we'll have to keep a parameter on the number of events that we have already picked. So let's say we have this p parameter, this is the number of events we have already picked, right? So again we'll calculate a j. How will we calculate a j? Using binary search, for binary search on this ei, right? So I get my j. Let's make it pseudocode. So let's write j equals to binary search on ei. Now what would our dp maximum answer be? So answer could be either, again we do not pick it, so that would go to I plus 1 p, so the number of picked elements remains same, or it could be answer comma, now we pick this, so we'll get vi plus recur I plus 1 and p plus 1. Now p becomes plus 1, and we'll finally return it. What would our base case be? So our base case could be that if I equals to n, so we do not have any elements, or we have picked two elements. So if we have picked two elements, that is p equals to 2. In that case, we do not need to make anything new, return 0. So yeah, let's go to the code. One thing I will give you I will show you I will make you understand the recurrence DP code. So like, okay, why can we use DP here? Because see, this will give us overlapping subproblems. Number of parameters that we have, number of changing parameters here is 2. So we'll need a 2D DP, but the number of states of this 2D DP would be, see, I can be as big as n, like I could be from 0 to n minus 1, right? And p can be from 0 to 2. So this would actually give me an 2n dp. So this is like linear only. Uh, so this is fine. So we can solve this in n time, but the transition time here is, because we are doing binary search, so we have number of stages 2n, and the transition time is log n. So that is why solution is n log n actually, right? Okay. What I was saying is I will show you and explain the recurrence DP code, or the memorization code, but you should try implementing this using the iterative DB. That would help you a lot in understanding this problem and understanding DP also. So I will also give you both the codes, like the recurrence code and the and memorization code, and the other thing also, the iterative DB code. Okay, so I got a lot of wrong answers. That's fine. Okay, let me copy to editor, and let me also make this black, just like, okay. So as I said, we'll first sort all the events. Then as I'm using a DP of arrays here, I use memset and set everything to -1, and the size of the array I set as maximum n being 1e5. Okay. maximum n being 10 is to 5 or 1 5. Okay. And then I call my recur function. As I said, we'll keep two parameters. One is for the event that we are currently on and the number of events we have already picked, because these are the only two things that actually make a subproblem or that actually defines a question, right? So base case would be that if we have run out of events or we have already picked two events, then we should return 0. Else we'll check if like a normal memorization code, that if we have already seen this subproblem, return its answer. Else what we'll do is first calculate all the starting of this, the ending of this, and the value of this event. So the first choice is that we do not pick this element. So do not pick. The other is that we pick this. So if we pick this as we saw, if we pick this as we saw, that int j would be the will basically binary search from I to n minus 1. So because we are at event I, so the next event has to be after event I, and it has to be between event I and n minus 1, and it has to have a start of greater than e. So this is not an inbuilt function. The upper bound function, if you use this, I was actually getting TL if we use the actual inbuilt upper bound function, because it has to do a comparison between vector and vector. So that is like it will have to, that takes more constant time. So that's why I implemented my own custom upper bound function here. So we pass the L parameter, the starting of the binary search, the R parameter, the ending of the binary search. I just do binary search on it. So if I go to the middle, I check if the middle start time is greater than x. So x, because if it is, then I just R equals to -1, else L equals to m plus 1. So this will give me the first index with s greater than x, and that is what we need, the first index which has the start time greater than e, right? And then I basically do answer equals to max of answer comma recur j. Now I'm picking this, so my p would get incremented p plus 1 events plus v, and finally we can return this and store this into our DPI. So yeah, this works. The time complexity is n log n, the space complexity is O of n, because we are creating a 2n array. Yeah, thank you for watching. If you were able to understand anything, give me a like, and also implement the DP iterative DP solution. It will teach you a lot. Bye.